This talk is on secure zero-touch P4 device onboarding and exposure via resource orchestration APIs. It's a joint work between UBITECH, University of Patras, and NEC. Nowadays, SDN controllers need to manage lots of different devices, ranging from switches, IP routers, different types of optical devices. And this is typically happening across multiple domains. Another thing that is important is that these controllers are usually connected with overlay systems such as orchestration platforms so as to be able to expose those network resources via standardized APIs. Typically, these APIs offer connectivity services from the SDN controllers as part of more complex services, such as, for example, end-to-end slices. In this talk, we will try to address two important questions. First of all, can we assume that all these devices in the underlying network are trusted so as to be onboarded onto the orchestration platform? For example, what if a compromised device attempts to be onboarded on the platform? The second question has to do with the network scale, basically. All these types of devices need to be onboarded, monitored, and at some point, some services are provisioned on top of these devices. If we are meant to do all these processes in a manual way, in a huge network, the time to consume would be extraordinary. So the question is here, can we automate these time-consuming operations? This brings us to the objective of this presentation, which is via an open orchestration platform, we would like to automate, first of all, device attestation for enabling secure and trusted onboarding of a network device onto an orchestration platform. After device onboarding has happened, this needs to be mapped to the resource inventory of the orchestration platform. And finally, comes the resource provisioning part and the service provisioning part in those devices, which require typically deep device visibility via telemetry and also different types of connectivity services. On the right-hand side of this slide, I also list indicative icons of open source activities, not only related to ETSI SDGs, such as OpenSlice and TFS, but also other components that participate in this demonstration, and they are all integrated to prove the concept. Why are those relevant for ETSI now? Within the course of this work, we have developed different integrations. First is an integration between ETSI OpenSlice and TerraFlow SDN via the TFS northbound API, mostly for connectivity and telemetry services. Then another integration between OpenSlice and the device attestation service for security purposes. We have uncovered new bugs in the TFS P4 driver and also added new capabilities. So deeper integration with P4 and TFS. 3 new P4 services for layer 2, layer 3, and in-band network telemetry based on an ONF project called SD Fabric. Integration of TFS with Stratum-based P4 switches. And finally, a new telemetry backend collector for gathering and reporting in-band network telemetry data based on a specification from the P4 org group. Let's see the workflow of today's demo and presentation. First of all, we would like to see what is the initial state of the system before starting this whole demonstration. Second, we have designed a service on OpenSlice, which is responsible for onboarding TFS topology in a secure and trusted manner. To do so, this service first invokes a P4 attestation service, and secondly, deploys the topology if the attestation outcome is positive. Finally, we go into the service provisioning phase for telemetry and connectivity services. Again, here we have another service designed in OpenSlice, which is responsible for provisioning the in-band network telemetry and then the connectivity services. Let's see the setup of the system and the initial state before we start phases 2 and 3. So our setup is rather simple. We have OpenSlice on top, TerraFlow in between, and then a P4 switch deployed on a VM, acting as a connectivity means between the two networks, the edge network and the corporate network. There's also a device attestation component, which is communicating both with OpenSlice to receive commands for attesting some device, and also the P4 switch, which is the attestation target. Let's see how we begin now. We start the system with all the control plane components in place, meaning OpenSlice, TFS, and the device attestation service. But in the VM, which is meant to host the P4 switch, nothing is deployed initially. Let's go from top to bottom. In OpenSlice, we have pre-designed the desired services, and these are onboarded onto the OSL catalog. TFS is also deployed, but it's pretty much empty. No topology is uploaded initially. And the attestation service is deployed as well, but no attestation request is being made at the moment. It is expected to happen via OpenSlice. As I said previously, no P4 switch is deployed in the beginning, but as a follow-up step, we will deploy a Stratum BMV2 switch, currently with no P4 program being provisioned in the data path. Therefore, the connectivity between edge and corporate domains is not established yet. Those domains are disconnected. So I will load a small demonstration to showcase this initial state of the system before we go into the next steps. So this is the OpenSlice portal. We log in here with an account, and we go to the services portal to see the marketplace. Here we see a catalog called Across from the project. And when we open this catalog, we see different services already being specified. If we go to the service orders history and we try to check what is happening in the last hour, we will see that no service orders have been made during the last hour. So OpenSlice is empty. Now this is the portal of TFS. As you see, no topology is uploaded on TFS at the moment, so this is expected to happen in the next phase. Now into the console. We have a console of TFS, which shows that TFS is deployed, that all the services are running. We see the pods are in running state, and also the exposed services with their IPs are visualized as well. So TFS is up and running. On the right-hand side, we have the P4 switch. We check first the configuration of the P4 switch, which is a BMV2 switch. As we see, there are 3 ports defined in turn, 2 data plane ports, and the last one is a port used for telemetry. And now we are ready to start the Stratum switch. The switch is loaded, it's deployed, but no P4 configuration is installed at the moment. And as you can see, there are 3 ports already connected via Stratum. Down there, we see also the attestation service. We issue a request there for the VM which hosts the P4 switch, and this gets an indication that it's not attested yet. And if we start the connectivity between the 2 domains, we see that the ping command doesn't work. So the domains are disconnected. So this takes us to the initial stage of the system. Now I will review my slides to explain the second part. The second part is how we can securely and automatically onboard the P4 switch onto the system. We start this, as I explained previously, via OpenSlice, which is the orchestrator of this whole POC. There is already a designed service there, which has to do with this onboarding phase. We start from the OpenSlice portal and we inspect this service. At the same time, we start logging the TFS NBI calls just to see when OpenSlice is going to call the TFS NBI to onboard the topology. And then we're ready to place a service order for this service from the OpenSlice catalog. When this is happening, first OpenSlice tries to contact the device attestation component to request attestation of the P4 virtual machine. This in turn happens between the device attestation service and the P4 VM, and the attestation results are returned back to OpenSlice. If the attestation result is successful, then OpenSlice requests TFS to bootstrap the topology, because now we are certain that the P4 switch is attested. Then TFS connects to the P4 switch and loads a P4 program onto the switch. But since this P4 program has no rules in the beginning, it's just the tables are empty, we still don't have connectivity between the edge and the corporate domains. Let's now see a demonstration of this. We begin again from the OpenSlice portal to see the available specifications. We filter those related to P4, and we see there are certain specifications dedicated to this demo. So we click on the first one, secure zero-touch P4 onboarding, and by observing this design of the service, we see at the bottom that this service invokes two other services. First is an attestation service, which tries to attest the P4 device before being onboarded. And when this is successful, then we invoke another service which onboards the topology via TFS. Going now to the terminal, here we employ a script which shows real-time logs of the TFS northbound API just to see when the OpenSlice request is coming. And then we go back to the catalog of OpenSlice to order this service. So secure zero-touch P4 onboarding is the name of the service. We preview, we place the order in the order cart, and then on the top right-hand side, we go to the order list, we inspect the order, and we place it into the system. Now we're going to visit the service order history to see that the order is actually already placed. You see, it's already in an initial phase. And if we go into the service order, the first thing we need to do is to flip the state of the order to acknowledge. So the administrator of the platform needs to acknowledge this service before proceeding. So we flip the state, and now this tells OpenSlice to start executing the service order. We see now the progress, the order is in progress, and OpenSlice starts processing. The first thing that happens is that the attestation service becomes active. If we click there, we see the details of the attestation service. And in the characteristics, we see the response, meaning that this has already started. We confirm this in the terminal by looking into the, oops, sorry, I missed some. Sorry for this. So going back to the terminal, we see that if we invoke the attestation service here, we see a successful result. And then we go back to the portal to see that after the attestation service, OpenSlice has already triggered TFS to onboard the topology. So the attestation status is successful and TFS has started the onboarding. The order now is completed, and now we can move to TFS to see that it really happened. First, we see the logs, the trigger has happened, and the TFS portal shows actually the topology. We see a TFS controller instance, a P4 switch, and two domains, the edge and the corporate domain. We also see the list of devices here with a P4 device already being there. As you see from the portal, this device has 3 ports, as we explained previously. It's already enabled. And we can also inspect the configuration of the device. such as IP address, the port number, some information about the P4 program that is loaded onto the device. And at the very bottom, we also see the 3 endpoints that are configured. If we go to the service tab, here we see that there are no services installed yet, and this is why we don't have connectivity. So if, again, we attempt to ping from one domain to another, the packets are not going through because the P4 program doesn't have any rules. Let's now go to the last part to actually provision a service and establish this connectivity. And this is actually the last part of the demonstration. So zero-touch P4 telemetry and connectivity. Again, we start with another service on the OpenSlice catalog, which tells OpenSlice to hit the Teraflow SDN APIs and provision 3 types of services, 1 for in-band telemetry and 2 more for connectivity. We place the order onto the OpenSlice portal, and this creates this set of requests for TFS to provision these 3 services, 1 for telemetry, 2 for connectivity. TFS instructs the P4 switch with some rules dedicated for these 3 types of services. And then we suddenly see connectivity between the 2 domains as the packets can now go through the P4 switch. Because we have already installed an in-band telemetry service in the switch, every time that the packet goes through the P4 switch, an INT packet and telemetry packet is sent from the switch to the Teraflow SDN controller to report the network state of the device. Let's now see again the last part of the demonstration. The process starts again from the catalog of OpenSlice, which goes now and selects the P4 telemetry and connectivity service. We place the order in the list, and then we order the service directly from OpenSlice. If we go to the service order history, again, we see the service being initiated. And clicking on the details of the service, we again have to do the same process. So acknowledge the service order before being dispatched to the orchestrator. When we do so, OpenSlice picks up and puts it in progress. We see 3 API calls to TFS on the console. And suddenly now you see the ping connectivity has already started because the 3 services are installed. The order is completed on the OSL side, and we see here some responses that OpenSlice got from TFS regarding the connectivity services, 1 for layer 2 and another for layer 3 connectivity. And now if we move to the Teraflow portal, we see 3 new services. If we refresh the view, the devices, again, we have an updated configuration in the P4 switch. Before we had 6 rules, now we have 39. So all in all, we have 33 new rules for the 3 types of services that we installed. You can observe here the rules. And if we also go to the Grafana portal, now we also have the reporting of the in-band network telemetry. So the P4 switch latency to move those ICMP packets through the SD Fabric pipeline is showcased on the graph. Now let's conclude the presentation. I hope I didn't go over the time. The team behind the POC, myself, Kostis Stratos from University of Patras, who is also ETSI OpenSlice TSC chair, and Felix Gladke from NEC. This is a joint work. About the impact of this work, well, we have different open source projects here on the left-hand side of the slide. OpenSlice, TFS, SD Fabric, Stratum from ONF, P4, with a specific specification about in-band network telemetry. Those open source projects make use of standardized APIs coming from TM Forum on the OpenSlice side, ITF in Teraflow. Obviously, ETSI is the SDG host here. And you also see the mapping here of partners with the various components used in this work. About the NEC component, which is a closed source component, the device attestation here is using trusted platform modules, which is a hardware, let's say, feature of most platforms nowadays, but also some aspects of the Linux kernel, like the integrity measurement architecture, which is extended by NEC to support containers, and also some eBPF hooks into system calls for extracting important security information. That was all. To acknowledge the work that funded this demonstration, we are working both in the Across and P2 Code projects in similar aspects regarding network services, with P4 especially. So both of the projects are funding this work. Thanks a lot, and happy to take any questions.